We will be solving applications that involve quadratic equations, and we'll do so in 3 parts. So the first type of application problems that we will solve that involve quadratic equations will be what I'm calling type 1, which are either number or area problems. So to outline the steps that we will be taking in order to solve these application problems, the first step that we're going to take is you need to take some time and ask yourself, what are we trying to find? And then I encourage you to define your variable. So often those are thought of as, say, let statements. So we're going to let, say, n equal the number, and we'll work with that together. The next step is to determine what equation or equations can we set up to represent the given information. And then how can we solve this problem? And then always make sure I found an answer, but does it actually make sense? And then within that, is there an answer or answers that we need to reject? So finally, you want to finish up with determining what is the answer, and also, is there more than one possible answer? So our first example, we're looking at 3 times the square of a positive number decreased by twice the number is 21. Now often, but not always, often in, let's say, word problems often is denoted by an equal symbol. And so we're really at step A, which is, what are we trying to find? And we're trying to find the number. So we're going to define a variable. So we're going to let n equal the number. And what do we know about this number? Well, we know, and take this slowly, we know that 3 times the square of this positive number. So let's write that down. 3 times the square of this positive number is decreased, which means subtraction, by twice the number, which means multiplication. And as we talked about, it is 21, which means it is equal to 21. And notice that is quadratic. And so with solving quadratic equations, there's a lot of different methods. And a method that we have talked about is factoring. And so let's see if this is factorable by first setting it equal to 0 by subtracting 21. And notice our leading coefficient is 3, our b is -2, and then our constant is -21. And we do not have a common factor, so there's nothing we can factor out that each term has in common. Now 3 is prime, so if this indeed factors, it has to have factors of 3n and positive n. Now 21 is not prime, but it only has factors of 1 and 21 and 3 with 7. But because we said there is no common factor, I know that a 3 cannot be put here, and a 21 could not be put here, because that would indicate that we have a common 3 with this 3n. So that limits our possibilities for this space right here. So if we think about the fact that we have -2n, our largest outside or inside product is going to have to be the -1. And notice we have -21. So one of this is going to have plus, the other one is going to have minus. And because this is -2n, I'm thinking that we want to use the factors of 21 of 3 and 7, because those are pretty close to each other. 2 is rather small. It's not a large number. So again, 3 cannot go here because that would give us a common factor of 3, which we said we don't have. So I'm guessing, and this literally is a guess, I'm guessing the 7 goes there and the 3 goes there. Now that gives us our 21. And because it's minus 21, we want to have a difference of 2. So if you look at 3n times 3, that gives us 9n. And then 7 times n, that gives us 7n, which does indeed have a difference of 2. And we want it to have a negative difference of 2, so the larger product must have the minus with it. So that's going to give us minus 3 and plus 7, which does indeed result in a minus 2n. Now we're going to set each factor equal to 0. So 3n plus 7 equals 0, which means 3n equals negative 7, which means n equals negative 7/3. And we need to reject that because remember, our number is supposed to be positive. Or n minus 3 is supposed to be equal to 0, which means n equals 3. And this is a positive number. Therefore, the number is 3. For question number 1, for the situation, the product of 2 consecutive numbers. Now remember, consecutive means they're right next to each other. So that means they have a difference of 1. The product of 2 consecutive numbers is 702. Which equation can be used to find the numbers? For your next question, your job is to write an equation. So this is going to be an open-ended question, not multiple choice. Write an equation representing the fact that the product of 2 consecutive even numbers is 288. Now, even numbers, think about the relationship between 2 even numbers. What is the difference between those 2 numbers? Our next example, we are given that the width of a rectangular box is 8 centimeters. Now let's take a moment and think about what a rectangular box actually looks like. So this is not a rectangle, that's different. A rectangle is 2-dimensional. A rectangular box is 3-dimensional. So we'll think about the fact that this box is based upon a rectangle, but it is 3 dimensions. And we are given the fact that the width is 8 centimeters. So I'm going to say that this is the width. I'm just making a choice. So the width is 8 centimeters. Now we also know that the height is 1/5 the length x. So we don't know what the length is, but we are told to let it equal x. So x is the length, and then the height is 1/5 the length x. So the height is 1/5 the length x. So 1/5 of x. And then the total volume is given as 640 centimeters cubed. Notice again, that helps us understand that this is three-dimensional. It's volume, and our volume formula for a rectangular prism is volume equals length times width times height. And we are giving 4 pieces of information. We are given the fact that the volume is 640. The length is x. The width is 8. And the height is 1/5 of x. Simplifying the right-hand side, x times 8 is 8x times 1/5. Notice 8 is in the numerator, 5 is in the denominator, and x times x is x squared. Notice this is quadratic. Notice also we have an equation with a fraction. So we can get rid of this fraction by multiplying by 5, but we also want to get rid of the 8, don't we? So we're not only going to multiply by 5 on each side, we're also going to divide by 8. Now we got to keep this equation balanced. So if I multiply the right side by 5 over 8, we're going to multiply the left side by 5 over 8. And if I multiply by 5, it eliminates that denominator of 8. Pardon me, the denominator of 5. And if I multiply by 8, it cancels with this denominator of 8. So the 8 and the 5 cancel. Now 5 times 640 is 3,200, but divided by 8 gives us 400. So 400 equals x squared. And this is a great review problem because notice now we're going to use the square root property. We're going to solve for x by taking the positive and the negative square root of 400, which means x is equal to positive or negative 20. But this is a length, so we need to reject the negative, so that means x is equal to 20. And this is a length in terms of centimeter, so x is equal to 20 centimeters. And then remember the height is 1/5 of x, and 1/5 of 20 is 4 centimeters. So this rectangular box has dimensions of 8 centimeters wide by 4 centimeters high by 20 centimeters in length. So that's our length, this is our height, and our width was given as 8 centimeters. And question 3, for the situation, the width of a rectangle is 3 inches less than the length, and the area of the rectangle is 10 inches squared. Which equation can be used to find the length and the width? And we're going to let L equal the length. And last question. For the situation, a rectangular garden measures 5 feet by 4 feet. The length and the width are both increased by the same amount, and we don't know that amount. It is given as x. And the new area is 56 square feet. which equation can be used to find the new dimensions of the garden.